Hello my dear friends, welcome to my YouTube channel ADC Maths. This is the lecture video. I am going to solve two more problems under the Lagrange's linear equation model. What is Lagrange's linear equation model? Is of the format PP plus QQ is equal to R model. So I am going to consider two problems in the same pattern, but two different techniques. Our ultimate aim is to get the two independent solutions from the Axillary equation. So what are the Axillary equation first of all? So let us write the Axillary equation. In this problem, capital P is y squared z by x, capital Q is x is z, capital R is y squared. So what are the Axillary equation? The Axillary equations are dx by capital P. What's the capital P? Y squared z by x. What about dy by capital Q? So this is my Q, this is my P, this is my R, right? So it is x is z. Then finally dz by R, that is y squared. So this is my axillary equation. My aim is to get the two independent solutions. So I can start from 1 and 2. So from 1 and 2 ratios, of star equation, I can rewrite this by x dx by reciprocating the denominator. X dx by y squared z is equal to dy by x z. Once again, please keep in mind the denominator is dx and dy. So please retain the x and y variables alone. Other than the x and y, please try to cancel. So after cancellation, I can grouping the terms. So let us grouping the variables. This is called the method of grouping technique. Cross multiply the x this side from the left hand side, which is from the right hand side to left hand side. We get x squared dx and is equal to, let us cross multiply the y squared to the next side from left to right. We get is y squared dy. Now they are grouped. Left hand side is x alone, right hand side is y alone. Now when I integrate it, we get this x cubed by 3 is equal to y cubed by 3 plus some constant is also a by 3. Otherwise, u is equal to x cube minus y cube is equal to some constant a. Got it? I need the one more independent solution from the other ratios of star equation. Let us see that in this problem, if I choose the second and third ratio, what will happen? Let us see that if I choose the second and third ratio, here y, here is z. So when I consider in the second and third ratio, by cross multiplying the y, we get is y square dy. When I cross multiply to this term, we get is x is dz. So here y square dy is group, no problem the left hand side, but the right hand side z dz. What about x? X is also a variable. So by choosing the second and the third ratio, it is not the best idea to get the second independent solution because of here x was present in this right hand side. So what I suggest you that the last possible combination is when I pick the first and the third ratio. What's the first and third ratio? Dx and dz. So can I choose the first and third ratios of the equation star? I am getting that x dx by y squared into z is equal to dz by y squared. Once again, please see that here x, here z. So please retain the x and z. Try to eliminate the other variables. So I found that y squared is going to cancel. So let us cross multiply to the next side. Let us grouping the terms. We get x dx is equal to z dz. So once they are grouped, go for the integration. So I am getting that x squared by 2 is equal to z squared by 2. What is z? Z is the function of x and y. That's already known. So by this way I am getting that as a b by 2 or otherwise. So x squared minus z squared is equal to some b. So this is my second one. So what is my required general solution? Is the format phi of u comma v equal to 0. So let us substitute u is equal to x cube minus y cube because this is the u, correct? And v is x squared minus z squared. V is x squared minus z squared is equal to 0. So this is the required general solution. Clear? Now, okay, this problem is now we can get the answer because of by using the first and second ratio, by using the first and third ratio. Second and the third one doesn't work actually, it is failed actually. So I can choose the other option. But even though in sometimes when I pick the other combinations like 1 and 3, suppose we are unable to find the second possible independent solutions, what we can do? Sure, that is a good question. Let us see the way to find the second independent solution from this problem. So let us see this second sum. The second problem once again is z into x plus y is equal to x squared p plus y squared q. This is looks like pp plus qq is equal to r model. Right, sir? So correct? So once again this comes under Lagrange's linear equation. pp plus qq is equal to r. So can I use the same idea to write the axillary equation here? Can I go for the axillary equation? So what are the axillary equation? Dx by capital P. So dx by x squared, dy by capital Q, that is dy by y squared, and dz by z into x plus y. So once I repeat that, in this problem pp plus qq is equal to r model. Capital P is x squared, capital Q is y squared, capital R is z into x plus y. So this is the axillary equation. Now I would like to find out the two independent solutions from this star equation. Can you see the first and third ratio? Can you see the first and third ratio? Can you see the first and third ratio? I think so. This is x, this is y. So naturally they are grouped. So can I pick the first and the second ratios of stars? I am getting that dx by x squared is equal to dy by y squared. So they are naturally grouped. So I can go for that integration. So what is x power minus 2 dx? Here it is y power minus 2 dy. So when I go for the integration, this becomes x power minus 2 plus 1 by minus 2 plus 1. In this side, y power minus 2 plus 1 by minus 2 plus 1 plus some constant e. So this is equal to minus 2 plus 1 is minus 1. So x power minus 1 by minus 1 is equal to y power minus 1 by minus 1 plus some constant a. So what is x power minus 1 represents 1 by x. So what I am getting that left hand side minus 1 by x is equal to the right hand side minus 1 by y plus some constant a. Otherwise minus 1 by x plus 1 by y is equal to a. So this is my u. So u is equal to minus 1 by x plus 1 by a. Y is equal to a. So I got the first solution. What about the second one? Yeah. Now once again, looking the ratios in the given axial equation. Suppose if I compare the second and third ratio, what happens? Yeah, second one is in terms of y, but third one is z as well as x plus y. So by choosing the second and third one, the grouping doesn't work directly. One more possible way is, can we choose 1 and 3 even though the same problem, because in the third ratio the denominator is z into x plus y. So again the grouping doesn't work there directly. So I would like to do some other techniques. What I would like to think, can we rearrange by using some properties of ratios? Yeah, see that here I am having x squared, here I am having y squared. I want to cancel this x plus y. So this is my activity. Then what is the grouping is possible? So what can I do? Do you remember that? What is x squared minus y squared? If you remember this identity in the algebra, x squared minus y squared is nothing but x minus y into x plus y. Is that right? So once if you remember this identity, now it is well and good. So when we will get x squared minus y squared from the star equation, when we get x squared minus y squared from the star equation, this is the ratios, right sir? So when we get x squared minus y squared in the denominator, when we subtract the 1 and 2, when we subtract the 1 and 2 ratios, I am getting this x square minus y square in the denominator. And let us equate this idea into the third ratio. So what is my suggestion is, once let us look out the denominator terms. Sometimes the grouping doesn't work directly. Let us try to use some kind of algebra idea, that is some identities, or sometimes we can use some properties of ratios, sometimes we can use some method of multipliers techniques like that. So in this problem, I would like to combine these two by subtract. So dx minus dy, they are the ratios. So once we subtract the numerator, what about the denominator? Again we subtract. And just equate this into the third ratio. I do not change anything in the third one because I know this is the identity. It is x plus y. So my aim is to cancel the x plus y. So that's why I don't do any modifications in the third ratio. So now in this second, that is the left hand side, the denominator. The numerator is dx minus dy. So by using the linear property, it is nothing but d of x minus y. What's d of x minus y? Is nothing but dx minus dy. What about d of x plus y? dx plus dy. So it's called linear property. And the denominator, I am having x square minus y squared. Can I use this identity? I am getting that x minus y into x plus y is equating to the third ratio, dz by z into x plus y. So this is possible only in the case of ratios. In the case of ratios, this is possible. We can add, we can subtract, and equate the third one, or equating the other two sums or other two subtractions, we can do whatever it is. Now, after doing this step, I found that I want to go for grouping. Let us see that. So here x minus y, here also x minus y. So this somewhat is group. Here is z, here is also z. So this is somewhat is group. Other than this, which one is present? X plus y term was present. I think so. This term can cancel the x plus y from both the sides. So the rest of the term is d of x minus y by x minus y is equal to dz by z. So I think so. They are grouped now. So do the integration. What is integral d of x minus y by x minus y? Is nothing but log of x minus y is equal to log z. So the constant is also in terms of log. So what is log of x minus y minus log z is equal to log b. By using the properties of logarithms, log m minus log n is nothing but log m by n. It's called a division rule. It's called the division rule in logarithm. Log m minus log n is log m by n. So I can rewrite the left hand side by log of x minus y by z is equal to log b. After taking the exponential term, automatically the log term will cancel. So I found that b is equal to x minus y by z is equal to b. So this is the way to get the second independent solution. Suppose the method of grouping doesn't work. Right, sir? So once we get the v, already we found the u as well. Hence the complete solution of this. Hence the complete solution of this equation is phi of u comma v equal to 0. So minus 1 by x plus 1 by y comma x minus y by z is equal to 0. What about z? Z be the function of x and y. So let us see that these two are two distinct as well as the independent solutions. So this is the very interesting topic in the first order non-linear partial differential equation. What is called non-linear? It sometimes may have power more than 1. So it's called non-linear. And even though there are many techniques are there, one is the grouping technique. Sometimes grouping is not possible. Let us using some properties of ratios. Sometimes when we fail to use even though the properties of ratios, then again move on to the final technique is known as method of multipliers. So the next video I am going to deliver in detail about the method of multipliers. Until then, hats off to you. Take care. Bye. Thank you.